Okay, so before watching this video, please give it a pause and try out the problem to see if you can get it. Alright, let's give it a read. At a certain location, the horizontal component of the Earth's magnetic field is 2.5 to the -5th Tesla due north. A proton moves eastward with just the right speed for the magnetic force on it to balance its weight. Find the speed of the proton. Okay, so I think starting off with, we are going to use the right-hand rule, and because this is a proton, so we are going to set our thumb in the direction of the velocity of the proton. So it will be our thumb, and then our fingers will point in the direction of the magnetic field. So velocity, and then the B, field. And since our palm is facing out towards us, the magnetic force will be out of the page. So denoted by, think of an arrow shooting out towards you. Okay, so now that we have that, we are going to think about what the force of the magnetic field is. So that is going to be, the force is equal to the charge times the velocity times sine theta times the magnetic field. So now that we know that the force is coming out of the page, we know that, and the velocity of the proton is going in an eastward direction, that is going to be perpendicular to the force. So theta is going to be 90, and sine of 90 is going to be equal to 1. Okay, so let's read this part here. So a proton moves eastward with just the right speed for the magnetic force on it to balance its weight. So for any physics problem, you want to think about what forces are acting, and if there is going to be a net force, or if the forces are in equilibrium. And so in this problem, the forces, it's going to balance its weight, so the forces are going to be in equilibrium. So we are going to have the force of gravity, which is equal to the mass of the proton times g, which is the acceleration due to gravity, which is 9.81 meters per second squared. Okay, and since these forces are balancing, we are going to set these equations equal to each other. So it is going to be the mass of the proton times gravity is equal to the charge. And I'll write this here just to make it clear. Force of gravity is equal to, in this problem, to the force of the magnetic field. And then, so it will be times the velocity, and we already figured out that sine theta, which is that its theta is going to be 90, so that's going to be equal to 1. So we'll just have Q times V times B. Okay, and we're looking for the velocity. So what we're going to do is we're going to divide over Q, the charge, and B, the magnetic field. So what we'll have is V is equal to the mass of the proton times the gravitational acceleration divided by Q, the charge of the proton, times the magnetic field. And in these problems, it's been very helpful for me to solve everything out algebraically and then plug in the numbers, because you understand where you're at and you're less likely to make an error. So let's start plugging in the numbers here. So the mass of a proton, you should be given this number, or you can just search for it. It is 1.67 times 10 to the negative 27th kilograms. Like we said earlier, acceleration due to gravity is 9.81 meters per second squared. Divide that by the charge of a proton, which is 1.6 times 10 to the negative 19 coulomb, times the magnetic field that we are given, which is 2.5 times 10 to the fifth to the negative fifth Tesla. And also another good trick is to always write out the units, because if you know your units, you know what your answer should be in, and it'll help you solve any errors that you might have made throughout the problem. So then after we solve this, we should get a velocity of 4.095 times 10 to the negative 3 meters per second. Okay, hopefully that helped. Let me know if there's any other questions that you had, or if there is any questions that you would like me to do videos on. Thank you.